Hey YouTube, I just wanted to give a quick summary of the software that I wrote senior year. This is a prototype for our senior acoustic modeling competition in our class at Columbia College in Chicago. And this is mainly for resume purposes for potential employers so they can kind of get a peek at one of the items that is on my resume. Start things off, you've got your room here. And then the main function is going to be when you hold spacebar, it brings up a list of menus that you have access to. So two of the most important ones are going to be the room editor. So you've got your surface materials, and then you've got your dimensions and even camera controls. So with camera controls, you can control the zoom. So when you start messing with the room dimensions, you can get a better idea. You can hide three of the walls that are in the way of the viewport. And it's easy it makes it easier once you start adding materials to your room here. Dimensions, pretty standard. You can adjust. And it also goes between feet and meters. And you've got your 6 different surfaces for this square or cube room. You have a material library as well. So you can read the library that's already in there. We've got a number of different surface types that carry different parameters and textures as well. So let's say let's leave the wall, let's make the walls all brick, make it unglazed, and we'll make the floor, make a wood floor, and then plywood ceiling. So you can see surface has changed. If you want to get an idea, if you don't remember, you can hide the walls, get a better view inside the room, bring the walls back up. And so you can go into your material library. Now, this doesn't really tell you a lot about the acoustic properties. So you can go into your material library, and you can go ahead and you can read the library. And it brings up the list of materials here in this menu, as well as the absorption coefficients at the different frequencies here. And so let's say you wanted to add a material. So let's say we'll add YouTube as a material. Well, let's just say it's a full absorber, so we'll give it an absorption coefficient of 1 across the board. And then you add the material and read the library, and boom, you can see YouTube down here. These are other various little test things that I did for demonstrations. And these are all saved in a text file on your desktop, so you can share that with other people if they're using the software. It's pretty plain text readable as well. Exit that. And then let's pull up speed of sound, just kind of let you know. You can say the temperature in this facility, whatever it may be, which will affect the speed of sound. You can type that in. So let's say it's pretty cold. Let's say it's 0 degrees. So if it's 0 degrees and this is feet per second, if I change it to meters and boom, it will update to change to meters per second, or switch back to feet. Boom, changes to feet per second. And if I pull up, we've got axial and tangential nodes of the room. These are displayed here. There's more that are displayed than what's necessary, but just give full encompass. And when you scroll over them, it will play the tone. And if we also look at our various parameters, these are some of the other calculations that are made. We've got Schroeder's frequency, which is 90 hertz, almost 91 hertz. And we can get that to show up. It's got a little bit of a tolerance, but if you were, say, looking at the axial room notes on, this is length, width, height. And if you're looking, you can see that within this would be the Schroeder frequency. So these two nodes may be, some of the only two that really matter in this room here. You get mean free path as well as a critical distance within the facility. So let's go ahead and get rid of those various parameters. And the kicker that I think really won me the competition was the reflector graph. So if I go ahead and I can proceed to go to top view of the camera mode here, if I hide the walls, you can go ahead, you can add a listener and a source. So the listener height is, let's say it's 3. Oh, we're in feet, so let's make it 6 feet. And the height of the source, let's just say 8 feet. So we can add a listener, a little blue ball here. You can click and drag and move it around the room. You can't adjust the height, but you can adjust where it is in the space. So let's say we've got that listener is in, let's say, the back of a auditorium here. And we've got the source. So let's say this is a speaker on this side of the auditorium. Move this guy more towards the center. Press C, and you can see them in the space. And then the dBSPL of the source. So let's say it's a nice speaker. Let's say it's 100 decibels. And what you do is you can calculate reflectogram. You hit G. And it brings up, well, let's get rid of these. It brings up your graph here. And it provides the reflectogram graph. So this is the arrival of all the various reflections in the room. So purple is going to be the direct sound arriving. And so it was 100 decibels to start off with. And by the time it arrives, it's going to be somewhere around 75. And then after that, it's going to, there's going to be there's going to be 2 reflections that are first order reflections. So they only bounced off to one wall. And they arrive somewhere just after 40 milliseconds. And then you get some second order, another first order again. And you can see the absorption from the second order is you lose a couple dB. And then you have a nice little tail here. And that about wraps it up. Oh, reverberation times. That's a key one here. So this just gives you, based upon the materials you select. So let's go back to the room here. Let's pull up our surface materials. And so you can see the reverberation time should update in real time. Let's change the brick. We'll say it was carpet foamed. And you can see that should absorb more sound. So the reverberation times in the different frequencies will decrease. And so we'll have a little bit of a quieter room. Let's see how low we can get it. Let's put carpet on all of our walls. So there you go. We're at 500, right under a second. And 2,000 to 4,000. So this would be maybe even close to studio-like. Although low end, not too much absorption. We need to work on that. That is pretty much the gist of my software here. A lot of work went into this, about half a semester. If I could improve on some things, because this was done over the course of about, I would say majority of the work went in about 6 to 8 weeks. And if I could improve it, I would improve the layout, some of the menus here, maybe add some numbers to different surfaces and correspond over here, make it a little easier to use. Some better camera controls. It was a little lacking there. But with more time, I could have ironed things out. Worked on the UI. I really wish I could played more with getting this to scale properly. And this will also, let's get rid of the surface materials. This will also, the time down here, these nodes on the different axes will scale based upon the min and the max of the reflections as well as the amplitude as well. So that's the gist of it, and I hope you enjoyed watching.